Right, so with this question, we need to solve this, okay, in a range of 0 and 180. So what I would do to start with is actually write down what my range is, okay, because we need to adapt our range now, simply because the tan, it's not a tan of x, isn't it? It's tan of 2x plus 30. So let's adapt our range so that it's in terms of this, right? 2x plus 30. So let's take a bit of time, don't just do it in one go. Okay, you know, it's 2x, isn't it? So we could just change this to 2x to begin with. If you think about it there, you're doubling x, aren't you? Okay, to get 2x, you've got to double this as well then. Okay, and you've got to double that as well. But if you double 0, you get 0. Double 180, you get 360. So you've doubled x. And then, of course, you want plus 30. So I'm going to add 30 then to that. So you simply add 30 to this then, so you get 360 plus 30. And the same here then, add 30 to this, you get 0 plus 30. So the range then will be between 30 and 390 degrees. Okay, so we're going to find a solution now of this, tan to the minus 1 of root 3. Okay, and when we do that on our calculator, it comes out to be exactly 60 degrees. Okay, but that solution, of course, is for 2x plus 30, isn't it? Okay, so what I'm going to do now is find all the other solutions for the 2x plus 30, okay, in this range here. Okay, and then draw my tan graph. I'll have them. So it's got to be between 30 and 390. Now, it's a bit unrealistic to draw my tan graph from 30, so we'll actually do it from 0. That would make sense, right? Because if we do it from 0, it includes, if you think about it, it's going to include 30, isn't it? Okay, and again, it's going to be unrealistic to end at 390, okay, because usually we end at 360, don't we? So if we add 90 on, we'll go to 450, because that then will include the 390. So what I'll do here now, maybe every 3 centimeters again could represent 90 degrees. So 3, so 180, 270, 360, and 540, or 450 rather. So we've got 90 here, 180 here, 270 there, 360, 450 for our x. Okay, now remember with the tan graph, okay, it hasn't got an upper limit or lower limit. Okay, it just shoots off to infinity, okay, at 90 degrees. Okay, because, you know, a good way of remembering, of course, is when you type in tan 90 on your calculator, you know, type in tan 90 and it says math error. So when you see math error, it's shooting off to infinity. Okay, so you know, you might have forgotten where to start. Well, let's start at 0. Tan 0 is 0, and what happens is then it increases and it sort of tends towards that asymptote then. Okay, it never quite gets there, shoots off to infinity. Okay, so it's positive increasing there. If you can't remember which way the curve goes, just try a value on your calculator, put in, say, 45 degrees there, tan 45, and you'll realise it's positive and it's increasing, but it can never quite get there. Tan 90 is infinity, okay? Same here then, tan 180 is 0, and what happens here is it goes to negative infinity, okay? Again, you can check a value there in the middle just to see it's negative, okay? We need then an asymptote at 270. Because it goes to infinity there. We also need an asymptote of 450. Okay, so where it's equal to 60 degrees, we will draw a line. Now, I don't know where root 3 is on this axis. Don't know where it is, because remember, tan just shoots off, doesn't it? Okay, so we don't know where root 3 in terms of a scale here, but because it's 60 degrees, we know 60 degrees is roughly about there, isn't it? Okay, so I can draw that up to the graph first, and then draw a line across. So you can see then where it hits the graph, hits it there, and it hits it there. Okay, so our solutions are 60. That one there will be 180 plus 60, yeah, because it's the symmetry here that we've got with this. So it's across 60, it's across 60 there. and the same here, cross 60 there. So our solutions will be 60, 240, 420 based on what we did the calculation on in terms of the range here as well, okay, based on 2x plus 30. But that is what our solution is for, right? 2x plus 30 is equal to this. We want to find the solutions for x, remember, okay, for x. So what I do then is I adapt this then, I adjust it so we do get x. So I'll take that 30 over the other side and take away 30. Treat it like an equation. Take away 30 for all of them. So I get 30 degrees, 210, 390, and then we've got to divide by 2 from each of them, okay? So x will be 15 degrees, 105 degrees, and then when you work that out, that comes out to be 195 degrees. Now that last one is actually outside, isn't it? Outside of our range, because remember we wanted it between 0 and 180, so we can put an x through that. We can cross that out to say we don't want that one, but the other two are perfectly sufficient between 0 and 180.